This. All right, so today I am going to talk to you. Oh, first of all, hello, my name's Helen. Um, today I'm going to talk to you about how hacking and making has influenced music technology. We're going to go back in time and look at some weird sound art from the 1940s and the birth of electronic music. And then we're going to fast forward right to the present day and talk about some of the cool stuff that's coming out in music technology, weird sounding and cool sounding, and sometimes both, from London and Berlin. I'm currently based, more or less, in Berlin, so I do lots of music tech stuff there. I have brought, because apparently I never learn, I have brought some live demos. Which is a terrible idea, but we're going to see if they work. I made one of them in my hotel yesterday, and I think it's quite cute, but it does break a lot. So you're just going to have to forgive me. I do Twitter, so do follow me. I put loads of my makes up there. I'm less on Insta. I kind of suck at Insta, but if you're on Insta, add me. And there is my GitHub, which is largely full of very silly things. And I'll, well, I think that just broke, never mind. I will talk to you a bit more about some of the stuff on my GitHub later. All right, so I guess I'd probably better tell you who on earth I am and why this lass has been asked here to talk about music technology. So I do probably 3 strands of things. First of all, I design products. I also write stuff. You're probably most familiar with Hackaday, so I'm a writer for Hackaday. In fact, I am covering TEARDOWN for Hackaday, so if you have interesting projects, please bring them to me so I can do my deadlines. And I also make a lot of sound art and a lot of music using sound art. Now, art is a very loaded term, isn't it? Really, it's everybody. When you say art, everybody feels like they have to have an opinion on it, but really, it's just silly stuff that I enjoy doing to improve my technique and explore different possibilities. I'll talk a bit more about that later, but I thought I'd show you. Haha, yes. This is one of the products I designed. Most recently, it's sold on Adafruit, and P. Maroney manufactured it, which is like British Adafruit, essentially. That's my hand. I should have said I'm also a hand model. Very proud of that. I modelled that. I was lying on the floor of this manufacturing room, and they made me put it. And I've got really wonky fingers, so they photoshopped nail varnish onto me, and they were like, "Bend your fingers so you can't see how wonky they are." I was like, "All right," lying on the floor. It's not very glamorous being a model. Anyway, so yeah, that's my hand. I developed this. It's a gesture sensing instrument that is supposed to get children to learn to code. So they sew it, they wire it, they code it, and then they make chiptune-based instruments, so square waves, essentially. You can hack this. It's a $33 kit that's based on a $5,000 piece of equipment. I should mention, actually, I developed this for Imogen Heap, who's an artist and technologist, and she developed a very expensive MIDI controller, essentially, that uses gesture, flex sensing, and like a 9-DOF IMU to kind of create electronic music on stage. Ariana Grande took a bunch of them on her last tour, so they have been used professionally, and I thought I'd like to create something that was very, very cheap and that you could hack into making something very musical. I mean, I've actually been quite surprised by how many musicians use this. I will show you a stupid thing I made with it later on. But so that's an example of a product I've made. This is a still from one of my books. I have written a number of books, but this was the first one in my own name that came out at Christmas this year, published by McGraw-Hill. It's called The Crafty Kid's Guide to DIY Electronics. And I do a lot of writing for education, I guess, because that's how you get paid. You know, nobody pays you to write arty nonsense. And then this is an example of one of the sound art things that I do. So I really like materials. One of the reasons why I really enjoy craft-based electronics is because you get to play with some really interesting different materials, from embroidered circuitry to different types of materials to like flexible PCBs, which hopefully we should get some of that coming this weekend. But this is a circuit sculpture. I was inspired by everybody's probably seen Mohit's work on Twitter, and Jiri as well. It makes these amazing, beautiful, intricate pieces of art that are also functioning circuitry. And I thought, I really want to do that. But I went along to this music technology hack with the idea of making this beautiful, intricate circuit sculpture, and I got there and I was like, well, actually, I want to make something big and wobbly out of some cool materials. So I made, this is actually, that's not life-size. It's considerably smaller than that. I've made a tiny one. This is one of the tiny ones I made. It fits on a breadboard. I'll have it out later. I'll play it later as well. But this is a bass, and we'll hear it in a bit. Yeah, so that's about the size of a medium-sized dog, small to medium. But I've got one that's about the size of a chihuahua here as well, which is kind of cute. Yeah, so I make lots of different instruments. My favorite technologies to use are capacitive touch and gesture control, just because I think they're really expressive and you can do some really cool things with them. All right, so that's me. Here we go. Let's talk about music tech hacking. This is a very pretentious quote, isn't it? Love it. John Cage, very famous for doing his compositions, very strange things, including 4 minutes and 33 seconds of silence with a full orchestra. But John Cage was actually a hardware engineer as well. He made really cool instruments. And the point I wanted to make, really, in this bit is that music technology comes from weirdness. So stuff that has been something that is words. Okay, so Stravinsky, Debussy, Strauss, back in their time, they were considered to be weirdos and were booed off the stage and did these kind of compositions that really confused modern day people. And when we're going to, even like the violin, like in the 1500s, wasn't the violin. So the things that we think of as established music technologies are constantly changing. You know, so it's really interesting to look back through time and think about things that we take for granted that were revolutionary and weird sounding and usually just played in the basement to people who were nodding their heads but secretly having a bad time, which is like a large amount of bars that I go to. So here we go. This is a tape recorder, and this used to be really very modern technology. Back in the 1920s, I think it was first developed, but it became popularized in the 1940s after the war era. And this is magnetic tape, I should say, sorry. And this was the basis. Tinkerers and hackers and engineers used this machine to create a whole new form of sound. So if you think about a normal, hang on, how am I going to do this with one hand? All right, so if you think about a normal sound, we've got, this is a glass here. We all know what a glass sounds like when you tap it. But something that's interesting about about almost all naturally occurring sounds is something like this starts really quickly and then drops off slowly, okay? But when you record it on something like this, you're then able to take a pair of scissors or a scalpel, cut it, flip it around, and that sound is then in reverse. So it's got in music you'd call it decay, like how long the note takes to drop off. So it goes long, it starts quickly and it goes on long. So if you flip it around, you've then got this sound that doesn't occur in nature. And that's what Musique Concrète, we've got lots of really interesting people who worked on that. And you can go on YouTube and listen to lots of their really, really bad music. You can just really go down a hole. I mean, I think the reason I started talking about Musique Concrète rather than avant-garde music a lot earlier is that it's recorded from the 1940s. We actually have like a surviving recorder. You know, I mean, if I'm talking about Stravinsky, of course there were other weirder people mucking around with violins in that time, but they are consigned to the dustbin of history, you know, survivor bias and all that. But yeah, so Schaeffer and Stockhausen, two of the pioneers in Musique Concrète, and you can listen to some of that on the internet. But you can also, if you listen to music from the 60s, anything like by The Who, Floyd, the Beatles, hear their influence. So they made weird music. Right? What they actually did was develop a technique. They developed tools. They developed a way of working. So, and actually Schaeffer worked on the Beatles' Revolver album. So if you think about, there's a classic song, I can't embed YouTube in, otherwise I would have played it. There's Tomorrow Never Knows by the Beatles, at the beginning of that, you'll hear the whom kind of sounds. And that is classic musique concrète. It's backwards samples, essentially. But that was originally created by hackers making weird things. So I wanted to say that. So basically, their technique was to go around with a recorder. This is a modern day version. It's called field recording. This is just costs about $100. So Zoom H1N. You go around, you collect sounds, and then you can mess with them. In the old days, it would be just having a microphone on one of these. You go and record sounds, someone banging on a railing or sounds of trains or whatever. That's called field recording. And then you'd literally, with a scalpel and some sticky tape, slice them up, speed them up, re-record them, and then stick them together. And that's how you made music. That is analog, right? This is before the computers did this. You used to, until actually not that long ago, you used to actually physically cut up these samples. Work. So this loop transposition, which is like speeding it up to make it a different sound. And then literal sticky tape and scalpels. That's how they made a lot of music back then. Musique concrète, hackers making terrible music, but actually had a huge influence on modern day music and sampling. We're not going to follow the music route. Oh no, that's the revolver. I was going to probably tell about that. This lass. Who knows who this is? Nobody knows who she is. She's amazing. This is Daphne Oram, okay? Daphne Oram is probably the godmother of all electronic music. She was the first person to mix live electronic music and an orchestra, an analog orchestra, like human beings with their instruments. She was the first person to make a track out of pure sine wave that she recorded from her oscilloscope as well. She was born in the 1920s, and when you're born in the 1920s, you don't get to do interesting jobs if you are a woman, particularly not if you're working class. She was trained in physics and music, and then basically to get a job at the BBC, and they took her on as someone who lines up tapes, essentially. So she'd take the reels and she'd line them up and put magnetic, classical music back to back. But she went on a training tour to Paris, and she met a bunch of the people from Musique concrète, and they blew her mind. She went back to the BBC and she was like, look, this is amazing, this new technology. I know she knew about physics, she knew about electronics, and she had a classical background in music as well. And she was like, this has huge potential. And they were like, don't be ridiculous, go back to queuing your obviously. But she then, instead of giving up, she finished her day job queuing up music tapes, and then she off, steal the keys to the audio studio, steal a whole bunch of other things, slice things up, and work all night until she, 8 years later, managed to convince somebody to give her a platform for the strange music that she was creating. And it was just I think it was a sci-fi incidental music. And they were like, yeah, all right, Daphne, here you go, we'll give you this. But they loved it, the audience loved it, and she started getting more and more. And eventually, she was given the opportunity to open her own studio, a studio that is still iconic today. It's called the BBC Radiophonic Workshop. And she opened that in 1958 because she was becoming very, very popular. However, sadly, a year later, she left. She said that she was being pushed out of meetings. They wanted her. She said they wanted her ideas, they wanted her work, but they didn't want her. So she left. And she left to start up her own workshop, and she made the weirdest synthesizer of all time. It's called the Oramics machine. It's on display in the Science Museum in London. And it's basically these huge loops of clear tape, and you, with a watercolor brush, you draw on lines, and then something scans it and then creates notes out of the watercolor and painting. It's very strange. It's one of the early synthesizers, pure electronic stuff. So Daphne Oram, yes, she made the BBC Radiophonic Workshop and then was kind of kicked out. But we're not going to follow her weird. But she does have a book that's just been reissued called The Individual Note of Music, Sound and Electronics. So if you're interested in the physics of music and electronics, early electronics in music technology, would recommend you get that. I think they only printed like 3,000 for a Kickstarter. So, so the Radiophonic Workshop, I think that's most famous for is, do we know who this is? No. Okay, this is Delia Derbyshire. Do we know who Delia Derbyshire is? No. Wow. Okay. Delia Derbyshire is an electronic musician, an experimental musician. She's most for doing the Doctor Who theme tune. Those woo woo woo. Those are all handmade, stuck together with sticky tape, cut up with scalpels. Yeah, she's fantastic. I mean, actually, if you want to hear some of her music, there's loads of her music and Daphne Oram's music actually on YouTube as well. Really peculiar. But there's a great track that she wrote called Zooey Zooey O-O, which sounds like it's straight out of like a banging club track, and she wrote it in the 50s. It's really cool. So yeah, she's really interesting. But this whole era was really exciting because there was new technology to play with, a decent amount of budget, and there was new applications for technology as well. So basically, and the radiophonic work was essentially one of the first places in the whole world to be able to fully experiment with sound within an institution, which was kind of exciting. And this, I think, is a very hacky quote. I quite like that. So there was no such thing as an expert in that field. So they were just making stuff up as they went along. And it didn't really matter if things broke, and it didn't really matter if things were a bit hacky. And I think that's kind of a nice sentiment for making art with technology. Anyway, all right, so that's a whistle-stop tour of one piece of equipment, the tape recorder, and how it influenced. And the influence is still known today. Like, it's huge. Like, the whole area of Foley artists, which is like sound engineering, and lots of different modern techniques, all came from that original weird art collective in Paris in the 1940s. So I think it's important to recognize the roots of major technology innovations are sometimes a little peculiar. All right, so let's think about it. So that was cool, but what about now? So today we're having a huge boom in music technology. There's a number of reasons for this. One is electronics, as you know, are more and more accessible, and lots of artists are getting their hands on them, and there's a huge community. So I'm going to talk about that a little bit later. And I'll talk about it now, whatever. So, so something that I find really important, both for hacking and for my music, is thinking about the community in which it's placed. You know, it's tempting to think about artists and technologists and engineers as being this lone genius who doesn't really, who's there casting away, forging a path on his own, this whole kind of like idea of like Steve Jobs, the genius, the man, the polo neck, but actually it's community that's the most important thing. Even Picasso, who is, again, like someone who you see as this like dude who just knows how to be a genius just on his own. Like Picasso was surrounded by peers, surrounded by community that inspired him. There's a reason why he lived in the places that he lived. If it hadn't been for Braque and Matisse, Picasso would not have been Picasso. It's really important to place music technology or any kind of technology, particularly in communities like us, within the context in which they come. I wouldn't know half of the stuff that I know without being directly able to access community and ask people how they do things. It's really important. Why did I start talking about that? Oh yes, because you can do lots of cool things nowadays. So I'm going to tell you about some of the cool technologies that are really exciting me that you can have a go on. But first of all, no, I'm going to skip past that one. Oh, no, I'm not. Oh, that's cool. Okay, so I wanted to make the point that most makerspaces, decent-sized makerspaces, do have music hacking communities. And it's a really great way of learning about this. And you can often find... so this is Machine's Room. I was a hacker in residence there. It says in London, sorry. It doesn't exist anymore, obviously. They put the rent up 3 times. But this thing in the front here, this is also a musical instrument. It actually comes from this guy who's it's a guy called Tim Yates made this, and it's very simple. It's some sticks, some poles, whatever, wood, and a giant saw blade, and you just hit it with a hammer, and it's very simple, but it's one of the most effective pieces of it's just really satisfying. So you don't have to fill everything with electronics. But yeah, so hackerspaces, you can go there. Festivals, this is me and my friend Phoenix. There's actually really shit instrument that I made. It didn't work. The reason she's on stage is she had to reboot me every 20 seconds. Yeah. So this is EMF. Is a big festival in the UK. So festivals like technology festivals. I don't know what the equivalent in the US is, but in Europe we have something called CCC, which is like Chaos Computing Club. And every 4 years they have a summer camp, and every year they have a congress. And it's basically a bit like Maker Faire if everybody was suspicious of you and wearing black, and there were no children. So, I mean, that's what Congress is. Camp, I don't know, I'm going to my first one in August. But this is EMF, which was a spin-off from it. And it's like a Glastonbury for nerds. So instead of going to see a band, you might go and see Algo Rave. And instead of going to see stand-up comedy, you might see me being rebooted on stage. So, yeah, events like that are really cool. And then this is one of the key things for modern community and music tech is YouTube. Everyone's on YouTube. Has anyone seen this? Yeah, okay, right. None of you have heard of Delia Derbyshire, but everyone's heard of Sam. So this is Sam, who runs Lookman New Computer. And this is horrific. It is a church organ that he's hacked into a Furby organ. So it's a chorus of tuned Furbies, and it is honestly as bad as it sounds. I fully recommend you look at that up on YouTube if you want to ruin your day. So YouTube's great for that. Oh yes, this is what I wanted to say. Here we go. So these are the cool things you can do at home. I'm in a hacker space. You're all here because you make stuff, pretty much, or you want to make stuff, or you're just really lost. I want to talk to you about the cool hardware that exists at the moment, the cool software, and also a couple of different applications. So hardware instruments is usually like some kind of MIDI or OSC device using various, might use this. You can use pretty much any microcontroller or single board computer to make an instrument. They do things kind of differently. I would say my favorite at the moment is this one, this bad boy. This is a baler, and it's a cape to go on a beagle bone, and it makes use of the beagle bone's ability to be like super, super fast, to have incredible latency. Now, latency is just a term for how long it takes from doing something to the thing being, the output being done. And analog to analog on a baler is 0.1 milliseconds. So you can actually create a percussive instrument with this microcontroller. I mean, an Arduino, you can make an awful sounding theremin. Of course you can. But I mean, and the Pi, no shade, but it's like 9 milliseconds of latency, which means you can't use it for something that you pluck or something that you hit. That's just, you can hear that. It's unacceptable. But the baler is great. And the cool thing about the baler as well, which I really like, is you can drag on different programs, which takes me on to software, and I'll come back to baler in a hot second. So this is Pure Data. Okay, Pure Data is an open source piece of software, which is, it's used to make noises, nice ones. So when you go, a lot of people have made an instrument, right? But often they will sound really bad. We'll have if I hear another instrument that just uses like sine wave, I think I will cry because I don't want to hear that tinny nonsense. So you can then take the next step. Once you've made the actual controller, you can start making things that sound nice. And it's kind of important, you know, when you're making a musical instrument to also make music. That might be controversial. So this is a patch that I created. And basically, what you can do with a baler is just drag your noise onto the baler and then use it as an embedded thing rather than having to connect it to your laptops. So I'll take you through that in a minute. I'll do a demo because everybody wants that. Okay, and the other thing I wanted to say, software. So you've got Super Collider, you can use processing, that's great. Max MSP and Pure Data are kind of the same thing. They're written by the same dude. I've forgotten his name, but basically, I don't think he was too happy that Max MSP the price was jacked up, so he quit and created his own open source version, which is pretty identical. It's just got an ugly GUI. So would recommend Pure Data to trigger cool things. I'll show you what that does in a hot minute. And then if you wanted to have a go on making some music without hardware, why would you? But if you do, I know people like coding. There's something really cool that you should check out called Sonic Pi. And it is essentially, has anyone heard of Algo Rave? Okay, so Algo Rave is like one person. Okay, cool. So Algo Rave is kind of what it sounds like. It's algorithmic rave, right? It's what nerds do to party in certain parts of London. It's live coding music, essentially. And you project the code that you're creating at the same time as you're playing it. And it sounds banging, actually. There's a whole club scene. It's niche, to be fair. It is niche. It is niche. But it's really cool. And if you want to have a crack at that, there's a really awesome free, I think it's even browser-based, thing called Sonic Pi. Sonic as in, you know, Sonic, and Pi as in Raspberry. Although it doesn't use Python. I think Raspberry Pi just paid for it to be developed. But now it's like completely free and open. And it's super easy to have a go on. So if you want to, you know, feel like a rock star DJ, you can do that pretty easily. It's also great for teaching people to code who normally wouldn't care about code. So would recommend Sonic Pi, Algo Rave, having it large with code. All right, so here's some projects that I've done recently. I wanted to show you some cool. I've got enough time to do this. Let me put this in my pocket. Oh yes, here we go. So, some projects. Let me see if I can make some things work because, you know, live demos, they definitely always work. This is my friend Andrew. He is a composer and a sound designer, and this is a project that he's worked on before. So him, me, and Drew Festini, we worked on the Sonic Circuit Sculpture creatures, which I'll probably just play them and you can see what I mean. Let me see if it works. Does it work? No. Oh no, maybe. Is it going to turn on? Oh yeah, cool. 2 modulation. Wah, 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 wah. So that's something we made in an afternoon, and we've got one. I've got a mini one of that here with me. So if anybody wants to play with it, you can. That's just a Pure Data patch on a capacitive touch board by Baylor. They're about to bring them out, actually. I think they've got 26 cap touch pins on the board. It's great. I'm very excited. And then here's another one that I made as well. If it works. It does. Okay, cool. It's a messy one. So that one's a polyphonic creature. It sounds a bit like a harp, and it's made of steel wire. The first one's made out of brass rods, by the way. And yeah, so those are two creatures I made in collaboration with Andrew and Drew. And what's this? Oh, this is my... why have I put this here? Oh, yeah. All right, this is a robot unicorn I made after I did like a 4-month job writing curriculum on the most boring robot of all time. It basically just followed lines and had a distance sensor, and I was like, if I have to spend another minute writing curriculum for a line following robot, I'm going to cry. So I set out to make the cheapest, most stupid robot of all time. And it's extremely unreliable. It's powered by two 360-degree servos, which, as everybody who's used a servo knows, no two are the same. So some of them will go off in like weird loops. It's also, there's no H bridge. It's very cheap and very simple. Anyway, people love them, so I made a herd of them and did them with gesture control. And then this girl called Rena made me a leather version. She's a leather artist. I have got this. What's this got to do with music? Okay, so so she made me this. This is my evil leather glove made for summoning a robot army of unicorns. Yeah, I know I'm a ridiculous human being. But then I met this woman, Martine. Martine's literal job is, so she's known as the Moonbounce Girl. And she records, using a trusty Zoom recorder, she records instruments, and then she works with a group of astronomers with a satellite, with a satellite dish in the Netherlands, and she bounces the recorded samples off of the moon and then records what comes back. So I took a bunch of her samples of a cello being played and made it into a thing that works, hopefully, or maybe it won't. But I'll show you how it's supposed to work in the end. So let's get out of this. We don't want that anymore. I'm going to show you what's behind. Right. So all I'm doing here is I decided I wanted to see if I could make I mentioned the $5,000 MIDI controller that Imogen and so on made before, and I wanted to see if I could make a really cheap piece of equipment interface with my computer and interface with professional music software. So I'm using two of these in this hack. This is a microbit. It's a children's microcontroller that costs $10. It's basically indestructible, and there's millions of them. I mean, it's very popular in Europe. I think like the BBC gave away 1 million to children, every child of a certain age in the UK. So all I'm doing here is, let's see if that works. Could be, could not be. Yeah, okay, cool. So what I have here is I have a bridge. This is something called Hairless MIDI. It's a free piece of software. And this is just sending x-axis accelerometer data to another one of these cheap things, which is converting it then to MIDI signals, so 0 through 127, and then sending that data into my computer just via serial. And then this is a little bridge here, so it's going out into this, and let's see if I can make it work. I sometimes have to restart it, but let's give it a go, eh? Oh no. Right, let's see if that works. No. I don't have my glasses on either, which is probably an error. Oh no, that should work. Why is that not working? Oh. I know, I have to quit it and start it again. It's okay, don't worry. This always happens. It's the joys of open source software, isn't it? Audio on. There we go. Did I not click on that? I did a bad job. Where is it? No. Oh well, anyway, you can't hear it. But it sounds really cool. You just have to believe me. I don't know why it's not opening it up. well, whatever. Okay, well, it makes cool cello sounds, okay? And it also makes use of a GitHub library that I've recently put up there, which is just machine noises. Oh, crap. So if you are interested in hearing what a field recording sounds like, on my GitHub there is something just called machine sounds. So I go around and record cool sounding machines from makerspaces. And if you wanted to submit a cool sounding machine from your makerspace, that would be awesome. And sorry that didn't work. Live demos. It's okay, it's a hacker conference, nobody cares. Oh, and this is the last thing I wanted to talk about. This is a project I'm currently working on with my next door neighbor, Johannes, who some of you may know from his FPGA board, the Doppler machine. Some of you may know from TEARDOWN machines, which is essentially a MIDI out a robotic drum machine. So the cool thing about the glove, when my Pure Data patch works, which it wasn't, is that it takes analog data and then makes it into a MIDI signal. But this is the other way around, which is why I wanted to show it to you. Essentially, you draw a MIDI shape on it. I'll show you what I mean when I say a MIDI shape. So this, you can see here, you just draw something on. Okay, so you want this to hit there. And then you assign each of those. I'm not going to plug it in right now. But you assign each of those lines of notes to a different solenoid. A solenoid is just a motor that it goes in and out, right? It just goes bang, bang. And then you can create your own drum machine based around solenoids. So you're just drawing your MIDI. And this works on GarageBand and so on as well. It's just that I happen to have it in Ableton open here. So you can create like very intricate drum machines and percussive instruments that take MIDI in. So that was kind of two examples of cool MIDI products. And I think I've got to stop talking in a minute. I've lost my phone. Oh, it's in my pocket. Yeah, I do have to stop talking in a minute. But yeah, so basically this exists. It's a prototype of a tiny, it's like a, let me unplug it and I'll show you. It's this big. So this is the controller that allows you to take MIDI files and turn them into your own percussive instruments. This will be on, if me and Johannes get our shit together, it will be on Kickstarter later this year. I've got a working prototype with me. So if anybody wants to make a drum machine or a percussive instrument, I'm just going to be hanging around. So if you want to learn how to do it, I'm just going to be hanging out. I also have this with me. This is a tiny version. Look at it, so teeny weeny. It's a tiny, tiny version of a circuit sculpture creature. It's kind of delicate, and I need to calibrate the threshold for the cap touch because it keeps breaking, but it's here, you can play it. It doesn't matter if it gets broken. So if you want to have a poke, I mean, normally I would do them in a box because they'd be for display, but this one I made for y'all, and I know you don't care about boxes, so I've just banged it in a breadboard and left the wires showing so you can see actually how it's created. And this is the same for both of the instruments in the videos that I showed you earlier. So here we go. So I'll talk to you a little bit about it. So you can code it to do whatever you want with whatever software. But this is it's got two modulations. It's got like a delay, so it's quite short, and then it's got essentially a tremolo. No, it's just reset itself. Okay, well of course it did. Yeah, so it's got two different modulation settings and an octave of bass notes. But it does overheat a lot. So if anybody wants to help me figure out why it keeps crashing, help gratefully received. It's like part of what I'd like to do this week. This weekend is have a go on it. Oh, there's also going to be another instrument arriving, hopefully later today, but I don't know, which will be a Flex PCB prototype. So I'm quite excited by the possibilities of Flex PCBs. So I've made, with Drew, I've made a couple of different cap touch sensors, essentially, which we're going to hook up to an NPR 121, which is a cap touch board, and see how Flex works, because I think it would be really cool to have like properly moldable, wearable musical instruments, right? So this one's going to be I think I'm gonna do like like a necklace, but I don't know. But I thought it would be cool to do like a vocoder necklace. What do you think? I think that sounds cool. But like, it doesn't really matter. But when I've made that, when we've made that, we're gonna chuck it up online on GitHub for anybody to have a look at. Speaking of, what is your GitHub, Helen? Is that okay? I've only got 6 repositories, and I'm a kind of crappy coder, so please be kind. But I've got up there, I've got the full instructions for Robot Unicorn. I've got my repository of machine signs, which please, I do welcome people putting new weird signs on that repository. I've got all the stuff for the CapTouch creatures, including the pure data patches. You can just use those. If you want to make your own, just go on ahead and do it. It's pretty simple. What else have I got up there? Robot Unicorn, I already said that. Other things. Oh, and I'm doing a haptic homing device as well. That's going into a can dress, but that's nothing to do with music technology. But that's up there as well. So I put all my project files up on the internet, so you should check those out if you like. And that is my time. I think I've got time for a couple of questions. If anybody had any questions about Furby organs or capacitive touch or gesture sensing stuff or what it's like to go on tour with Imogen Heap, you can ask me. I think I've got to be off at like 15:15. Is that right? 20 All right, cool. So I've got 10 minutes of questions. So okay, how do we do this? I'm trying to figure that out. Oh, okay.
I suggest you.
Yeah, do you want?
And then repeat the question into the microphone. Yeah.
Okay, yeah, cool. Why don't you do that?
Okay, quick question about the gesture sensing. I was wondering if you played around with like edge machine learning for the gesture sensing, or is it like hard coded?
So I haven't played around with machine learning, but I know somebody who has. There's a woman called Hadil Ayoub who's a professor at Goldsmiths University, and she does a lot of gesture sensing, machine learning stuff. I have done, actually that's an interesting piece of software to use. I have done a little bit of dabbling in kind of, what do you call, I don't know the proper term for it, like taught machine learning. Rather than, it's not like particularly smart, you're just telling it what to do in certain circumstances. But there's a great piece of open source software called Wekinator, Wekinator, which was developed by Rebecca Feebrink at Goldsmiths as well, actually. They do a lot of machine learning stuff at Goldsmiths. And it's a tool for, it's like an entry-level tool for machine learning, specifically designed for artists and hackers to be able to have a go at machine learning. And then it's got really good integration with other existing tools. So, for example, Pure Data is one of the tools that can be outputted to, or processing if you're a visual person, or LED matrices, matrices, et cetera, et cetera. So for machine learning, definitely check out Wekinator. It's free. It's pretty simple. I mean, the documentation's reasonable as well, because it's come out of university. But yeah, no, I haven't. I am pretty excited about what Baylor are going to do with. So BeagleBone have got a new board called it's like an AI board. Is that out yet? Oh, you're from BeagleBone. Hi. Is BeagleBone's AI thing now available? Okay, cool. Okay, and but
I think it's gonna ship in September as the current plan.
Yeah, but Baylor have already got one, right?
Bella does have one.
Exactly. So Baylor, every time BeagleBone release a new board, Baylor create a new hat or cape, as they call it, which is very much more dramatic than a hat, isn't it? I like it. It's a cape for the BeagleBone, and so Baylor aren't like a big company or anything. They're actually based out of a PhD research unit in London called the Augmented Instruments Laboratory. It's a very cool place. But they make these cool capes for BeagleBone, and I'm really excited to see what they come up with for for this new BeagleBone AI. So I'm gonna wait until they've done something with it. But I have done like I've made Club Mate bottles sing and so on using Wekinator, which was fun. But yeah, nothing huge. So anything else? Anyone else want to ask me a thing, or shall I, just go and get coffee like everybody else? All right. What?
I have a microphone here.
Okay.
Do you have any specific recommendations for designing hardware that's designed to be durable for performance?
Ooh, yes, I do. So I often get brought in to teach creativity to engineers, but recently I got the opportunity to teach technology to musicians. I did a master's, I taught and wrote a master's module on sound creation to musicians, electronics to musicians. And this is a convoluted way of coming to your question, but basically something that really interested me is normally when I see engineers make instruments, they make them very much components first. And the musicians who had no experience, like I had to show them how to make their first circuit. Like they were like, "Oh my God, the LED lit up!" I was like, "Yes." Yeah, so they were like literally no knowledge of coding, no knowledge of electronics. Like literally copper tape circuit time it was. But by the end of it, they'd made these amazing musical instruments. And it's because instead of thinking about the technology first, they started thinking about the interactive experience that they wanted to create. And then were like, can I do this? And sometimes they'd be like, no, don't be ridiculous. And sometimes I'd be like, yeah, you can do that within the week that you have. So the range of instruments that were created by the musicians was very, very different to the kinds of instruments that I would normally see coming out of an engineering school, for example. So I do actually lecture on electronics and play at a product design focused school in London from time to time. And I do tend to see, even though that they'll create their own PCBs and their code is really good and well annotated and so on, but I'm like, oh yeah, great, amazing, another theremin, cool, like. But the musicians who had almost no knowledge actually came up with some incredible things. So when you're talking about, design's really interesting. So of course you've got to design for durability, but actually designing for playability and designing for joy and designing for beauty are also just as important. I think it's very easy to kind of forget the purpose of the instrument in the design of it. But I think if you're doing a wearable instrument, my top tip would be to do strain relief and use silicone wire in terms of practical. I don't know why everybody just doesn't use silicone wire all the time. I guess it's more expensive, but it's like the bomb. It doesn't melt with your soldering iron. It's usually much higher quality. It feels really nice against your skin. And I mean, like, why don't people? Loads of engineers, like, what is silicone wire? I'm like, it's the best. It's literally the best. So silicone wire, doing strain relief, so kind of double rolls of holes in your PCB essentially. That's really important. I would say it's really difficult to calibrate. So this thing that always kind of breaks, the capacitive touch bass creature worked really well in my apartment because I set the threshold in my apartment, right? You leave and you've suddenly got like very different levels with different numbers of people, different kinds of machines. So it's you do have to adjust the threshold quite often. And in terms of, what kind of, your durability issues, yeah, for the, make it removable. So I'm actually having this whole question with so I'm about to do a 2-month residency to create a kind of installation grade one of these sonic creatures, and I'm having the same kind of conversations with myself, like how on earth do I make like an art gallery level one of these when it breaks all the time, and the answer is not clear, but the answer is definitely, you have to have the PCB and the other thing. So basically, the thing I've broken quite a few of these and had to create them, and that's because transporting them, the joints stress. So I've sheared a whole bunch of through holes here. So I guess strain relief like whether it's kind of hard scale PC, like hard PCBs or soft PCBs or embroidered anything. Strain relief is the most important thing. It's usually wiring that's fucked up, right? Like it's never code. It's always wires. Yeah. Is that? I think that's not my time. No.
One more question.
Okay,
Any
cool.
other
One more
questions?
question, if there is one.
And you're gonna have this stuff to show off during the demo?
Yeah. No, I'll bring all my stuff around. Someone can even have one of the circuit sculpture creatures.
Hello. You mentioned working with Imogen Heap on her music and her performances. Are there other kind of larger musicians that are using music and technology together to create new forms of music and art?
Yeah, yes. There's lots of amazing musicians doing lots of interesting things with technologies. I'd say that Imogen's one of the more well-known ones because of this whole, because of the gloves. The gloves have been in the press quite a lot, and they've just been through another whole round of work. But I mean, I tend to look more at the creators of the instruments themselves, just because that's the world in which I live. If you're interested in kind of the kind of avant-garde, kind of cutting edge, kind of music hardware type stuff, I would 100% recommend that you go to a festival. It's kind of a conference, but it's a conference called Super Booth. And that's held every year in Berlin, and it's like half performance, half largely hardware nerds who've made strange instruments out of things, and also the big players as well, like Shaw and Sennheiser and Korg and Moog and all that. So that's a really good place to go and check out. Yeah, it's really strange. It's great. Okay, Super Booth, yay!
Okay, let's give Helen a hand.